Good afternoon, everybody, and welcome to our first workshop in a series of 4 online workshops. My name is Khalid.
And my name is Afaq.
Today we're going to be running through a workshop to help you guys with the basic programming for the EV3 and the basic building blocks of a robot.
Hey Khalid, why are we doing all this?
Well, we're mainly just trying to help out the teams who are in the first LEGO League. On that note, I'd also like to bring up that this is brought to you by the NYU Polytechnic School of Engineering in conjunction with NYU First.
A little about ourselves. We're actually undergrad students at the university, graduating this May, and we're more than happy to help.
Yeah, personally I'm a civil engineering, structural engineering undergrad.
And I'm a chemical biological engineer, hopefully, in May.
So we'd like to tell you guys a little bit about the first LEGO League competition, Afaq.
Well, the competition has a series of obstacles, as I'm sure you guys already know, and well, the whole point of this is to design a program the robot to go through these obstacles and get as many points as possible. In the series of these 4 workshops, each workshop will start getting harder and harder in difficulty in showing how to program the robot. But today, just basics building and getting the robot to move. So, Khalid, why don't we go through the parts? You have to help me name all these parts. What is this called?
Well, in fact, this here is the motor. At this time, I'd like you guys to also know that despite the fact that we are using an EV3 robot, and when I say EV3, this is what I'm talking about. It is the brain and the main brick of our robot. We're going to be using an EV3, but these motors, which are NXT motors, are backwards compatible and forwards compatible with the EV3. If you guys have any questions throughout the session, please feel free to ask us questions. Our email is, let's get that, center for K12STEM@gmail.com. As we were, Afaq. These guys here are motors. Here we have our EV3 brick. This is what we're going to be programming, and it basically sends out all the information to the motors and to all the components in your robot to allow it to traverse the competition field and do whatever it is that you want it to do.
Is that the only type of motor that can be used?
Well, this, if I'm not mistaken, is called a forward motor, and then we have our steering motor.
Do they come in different sizes?
They do not come in different sizes. So they're all the same size. Here we have basic LEGO parts. These guys here this is what they look like. We're going to be using these ones today. So if you have your kit, you should have a paper in the kit that basically shows you all the pieces that you have. Everything that we're using today, you should have in your own kit. Again, if you have any questions, please feel free to let us know. In fact, we're also going to be using our wheels today. You know, you need to move around. You got to be connecting these guys to your motors if you do want to make a dent in the competition.
The wheels definitely do have to come in different sizes, don't they?
Well, we do have different size wheels, and we also have different size tires. We can lightly touch on that kind of thing. The bigger of a tire you have, the faster you'll be able to go, and the more distance you'll be able to travel in less of a time. But the larger your tires are, the harder it will be for you to maneuver around the field. You know, when you have smaller tires, when you have smaller wheels, it's easier for you to maneuver. Furthermore, to connect your tires to your motor, you're going to need these little guys over here, which are axles, and these come in different sizes.
How do you know the sizes?
Well, in fact, I'm glad you asked. LEGO's done something really cool where you're able to use these sticks over here that has holes on them to measure sizes for your axles. So we can do this on screen. If you just place it up against it, measure that out, Afaq.
1, 2, 3, 4, 5, 6, 7. So this would be a 7-length axle.
This is a 7-length axle. So when we say things like 7-length axle, we just want you to stick it up to one of these, line it up, and measure against it. So what is that one you got there, Afaq?
That would have to be a 3-length axle.
Very good. Yeah. So the longer your axle is, the farther apart your wheels are going to be. The shorter it is, the closer it will be. The great thing about Legos is, and I don't know about you, Afaq, I've been playing with Legos since I was a young kid.
I've been stepping on Legos since I was a young kid.
We all know how much that hurts. With Legos, you get to take a creative license. So what we're showing you today, this is merely a suggestion. You can take it, you can build on it, or you can throw it away. This is just, you can get an idea of what we're doing. And on top of that, you know, we all have those little questions of, is this the same? Are you allowed to do that? Can I do this? I hope that we can kind of convey to you guys some of these points. So those minor little confusions that you kind of happen upon when you're building your robot, you're able just to get it out of there and build a really cool robot.
It's kind of like engineering in that sense, isn't it? We take upon what we learn and we build on it.
Yeah, but you get a little more sleep when you're involved in these competitions. Engineers, we don't get to sleep much. So, fact, we are going to be building something today called the 5-minute robot, and we actually do it. There is a tutorial for this online. If you go online and you Google it up, just type in 5-minute bot, and it should be the first result that comes up. But like I said, we'll be building it right along with you. You get to follow a step-by-step, and you get to see all the little intricacies and the little parts that are interchangeable. When I say something is interchangeable, it basically means that it can go in a different place from what I tell you. So these robots have motors that come with them, like we said before, and the motors are identical. They're symmetrical. So it doesn't matter what side of the robot you put the motors on. You could put it on the right side or you could put it on the left side. So what do we say that's called, Afak?
Interchangeable.
They're interchangeable.
Now, I am building this robot for the first time along with you guys, so Khalid will actually be showing me how to build this robot too. So if I can do it, anyone can do it.
Yes, if he can do it, you can definitely do it. Ready, Afak?
I'm ready when you are.
All right, all right. So the first thing I'd like for you guys to do is I'd like for you guys to get your 2 motors and place them on the side. So we got our 2 motors right here. Following, Afak? Then I'd like you to get your 2 wheels, Afak, and place those guys on the side.
That's 1 wheel. That's 2 wheels.
Put them by the motors. Let's put the EV3 on the side. We are going to need the EV3, but for now, just keep it on the side. Then, in fact, I'm going to need 2 7-length axles.
And again, I'm going to assume that these are these, but I will have to check with this. And again, 3, 6, 7. Again, the other one, 3, 6, 7. You don't want to start building and then find out you have a 5-length axle instead of a 7-length.
Why are you counting 3, 6, 7?
Well, instead of 1, 2, 3.
1, 2, 3, 4, 5, 6, 7. I don't know what he's counting by. And then we're going to need 4 bushings.
What's a bushing?
These little guys here, in fact, are called bushings. So to give you a little frame of reference of what a bushing is think of it basically as a holder. So eventually, as I'm sure you guys have kind of guessed, you're going to place your axle into your wheel. Now, you can imagine as you're kind of moving along, the wheel will start to come out of the axle. In order to prevent the wheel from coming off of the axle, in fact, we place the wheel and the axle together, and then we take one of these here bushings, right? Bushings.
Little things.
And we place them in the axle. Now, what this does is it basically serves as a holder for your wheel with your axle.
So it's kind of like a lock. It locks it in place.
It's kind of like a lock. Now, we're going to introduce you guys to a small concept called friction. When you guys have 2 surfaces that are coming in contact with each other, you get friction. Friction is basically what prevents something from moving when it's on something. So the more bushings you have, the more friction you have. Now, as you can imagine, the more friction you have, the harder it is for the wheel to rotate. So be very sparing with your bushings. Although they do keep your wheel stable, in fact, they will prevent your wheel from rotating as smoothly and as freely as possible.
But it also affects if I have the bushel up against
the bushing?
The bushing all the way up against either the motor or the EV3 or whatever I connect it to.
Well, here's the thing, in fact. If we have our axle and we place it into the wheel and we have the bushing coming into contact with the wheel, you're going to get a nice lock on the wheel.
Okay.
But on top of that, if you move the bushing outside a little, you're going to have a little bit of play. And if your wheel is moving and it's locked in, it'll go in a straight line. But if there's a little bit of play, the wheel is going to wobble. So you want it to be as tight as possible. Personally, my recommendation to you and you guys is have a bushing on each side of the wheel. It'll give it a nice firm lock. It'll keep you going straight. Any more than that, it's completely up to you. In engineering, what we do is we test these little things out. We see how they go. As you know, in fact, design and engineering is iterative. That means repetitive. So you build it, you try it, you test it. If it works, great. If it doesn't, go back to the drawing board, do it. The best things in this life have been repeated over and over and over and over. So we have our 2 7-length axles, in fact. And I said we're going to need 4 bushings. So if you guys can't see it, take my word for it. We got 4 bushings. So we got 4 bushings, 2 7-length axles, 2 wheels, and 2 motors. The first thing we're going to do is we are going to take our motors. Now you grab one, and I'll grab one, and we'll do it together. You guys can see, these guys can move around. We'll touch more on the power and the resistance that they'll give you to moving around. So, in fact, grab one of your 7th length axles.
Yes.
You're right. Now,
There's a lot of holes I can stick this into.
Here's what we're going to do. We're going to use the way it looks as a frame of reference. So I want you to hold it, in fact, so that this gray part over here with the little ridges is pointing away from you and pointing to the top. Okay. So the gray part pointing to the ceiling and away from you.
So it should look like this to the camera.
Yes, it should look like that. Then I want you to take your 7-length bushing, your 7-length axle, and I want you to insert it into the motor, into the orange part, in the middle part. You're going to see that there's a little cross in there, a little X, almost like a plus sign or a multiplication sign, depending on how you look at it. And you just got to stick the axle right in there. Can you do that, Afak?
Yeah. All the way?
Awesome.
Or halfway? Or?
Now, I want you to do it so that when you hold it, you have a long side of the axle on the outside.
Okay.
And no axle on the other side. So if you guys can see mine, it should be opposite of what a fax is, because we're going to have wheels on the outside. So this would be ideal. And if you notice, I switched the motors when I was doing it. It's completely okay. These motors are interchangeable. All you got to do is you just got to make sure that you have your axle on the correct side, and the wheels are going to be on the outside. If you're a little confused, stick with me. It'll all make sense. You ready with me, Fleck?
Yes, sir.
Alrighty. So, that being said, you're going to take one of your bushings, right?
Okay.
If we hold the motors out, the axles are on the outside. We're going to take one of the bushings, guys, and we're going to stick it on the outside. So when I say the outside, that means if I'm holding it in my right hand, the right side of the motor has the axle sticking out of it, and the right side also has the bushing sticking out of it. If you'd like to take a look at it, please do. And you can see mine and the fax next to one another. That's how it should look for you guys if you guys are following us and building this. Now, as you guys can see, me and the fax don't really have any part of the axle sticking out of the inside. Push it in just a little bit. Just a little bit. I would say about, I don't know, half the length of a bushing on both sides. Don't worry if you don't get it perfect. We'll be able to go ahead and adjust it. All right, Afak, you with me?
Yep.
Sounds good. Take it here. We're going to need to do our wheels next. So grab a wheel, Afak.
These wheels.
These wheels.
Yes.
Now, in fact, if you look at the wheels, there's two sides to the wheel. There's a deep side. You can almost stick your finger in the wheel. And then flat side. You can almost place things on it and they won't go anywhere.
So there's a deep side and a flat side.
What I want you to do, in fact, is I want you to take the flat side, and you guys too if you're following along with us, and on the outside of the motor, which means the part with the axle sticking out of it, place the flat side against the bushing.
So not the deep side.
Not the deep side, flat side to bushing.
So deep side facing me.
Deep side facing you. When you look at it from the outside, you should have the deep side like that. Let me know when you're ready, in fact. So guys, just to give you guys an update, this is what it'll look like, and if you kind of use your imagination, you can almost kind of see how this is going to take shape and turn into your robot. Hey, in fact, why do you think we placed the flat side up against the motor?
It's a good question. I wouldn't be able to answer that.
Well, if we place the flat side up against the motor, and guys, this is what engineering and design is. Just try it if you don't know what it is, and the answer will make itself clear to you. If we place the deep side into the axle, the tire is going to rub up against the motor, and that's not good, because when your robot is running, when you're on the field, it's not moving. It can't move. It impedes motion. You don't want that. We don't want that. We're not going to do that. But when you place the flat side on there, you're in business. All right, in fact, ready for the next step?
Yep.
So we got these two guys. We're going to place them on the side over here. We are going to revisit them. Now I'm going to need you to grab these ones over here. So the way these look, in fact, is that they have 3 sides on them. And if you count, they have on the long side 1, 2, 3, 4, 5, 6 circular holes. And at both ends, on this end and on this end, and on this end, in fact,
right,
they have a little cross. And then they have where the axles can go in. But we'll get there. Don't get ahead of yourself. So we're going to grab these two and we're going to put them on the side. Put one on the side for you. And then we're going to grab these 2 L1s. And these L1s have in total all circular holes 1, 2, 3, 4, 5, 6, 7 holes.
3 in the vertical.
Excuse me.
And 4 in the horizontal.
3 in the vertical, 4 in the horizontal. In total, there's 7 holes. There's nothing else that has maybe 2 in the vertical and 5 in the horizontal. So if you have an L and it has 7 holes, that's the one that you need. You got that, effect? Sounds good. Now, here's the part where you're going to have to do a little bit of counting, but it's okay. It should be in your kit. We're going to grab these little pegs. Now, the way that these little pegs look, effect, is that they have a little ridge in the middle, almost like a circle coming out on the center, and then a little hole in them. If I can get that up to the camera, I want you guys to see that. We're going to need 10 of these. So I'd like for you guys to get 10 of these. And since we're on YouTube and there's magic happening here, we already have the 10 ready. If you need to pause, feel free to do so. And then I'm going to need you to grab 2 of these. Now the cool thing about these ones is that, first of all, they come in different colors. We show him a fact. He has a blue one and I have a beige one. But on one side, they kind of look like the black connectors that we have from before. But they also have
axle.
They have an axle on the other side.
Yeah.
So this is kind of going to give you, it's a multi-purpose connector. You're going to be able to connect on one side using an axle, and on the other side, you're going to be able to use the peg connector. We're going to use this a peg. We're going to call this a peg connector. So keep one of those on the side for you, Afak, and I'll keep one of them on the side for me. And then I'm going to take 5 of these pegs, and you take 5 of these pegs.
That would make 10.
1, 2, 3, 4, 5.
That's 4. That's 5. Okay.
All right. So then the way we're going to do this, in fact, is we're going to take this long one that we had before. And again, if you guys are checking on it, it has a cross on the bottom and then 1, 2, 3, 4, 5, 6 of them. If the one you have at home is just like that, then that's the one that we're using. Now, first thing that we're going to do, in fact, is we are going to take our peg/axle connector.
The one that looks like an axle on one side and the connector on the other.
Exactly.
Okay.
And we are going to place the long side flat down on your table, just so you kind of know how to do it. Like that. And then you're going to place the axle connector in the top on the inside. That means
not the hole. Not the hole, right? The one that has...
Not the hole. You're going to place the axle connector into the top axle hole, the first connection on it. And you're going to do it on the inside of the connector. That means if you're holding it in your right hand, the connector is pointing to the left, and if you're holding it in your left hand, the connector is pointing into the right. So as you can see, they're pointing in towards each other. They're opposite but equal. And then, in fact, you're going to take one of your black connectors, your pegs, and then you're going to place it, not the first hole right after your axle pin connector, but the second hole. So do it as so.
Same way as our axle connector?
Facing the same way, in fact. So let's give him a look of how that looks. Give him a side view. Other way. There you go. Now, you're going to take another one of your pin connectors. And what we're going to do with this one is from the bottom, we're going to count. We're going to have a cross hole, then we're going to have a circular hole, and then we are going to go to the second hole after the first hole. And we're going to place one of our black connectors pointing the other way
facing outwards
from our axle. So this is facing outwards. Give them a look how that looks, in fact. And then we are going to do that again, counting to the first, second, third, fourth hole on the bottom. So basically, you have your peg, you skip one, then you go to the next one.
Am I right?
Look at this guy's getting ahead of me. So show him this side, show him that side. We'll put that on the side. Then we're going to take our L connector. This is the one that I said has 7 holes in it earlier.
3 vertical, 4 horizontal.
3 vertical, 4 horizontal, or 3 vertical, 5 horizontal. You can count it different ways. Frame of reference, always in engineering. You're going to grab your peg, and you're going to put it on the short leg on the last hole, or the first hole, depending on what you want to call it. And then, in fact, you're going to take this one, and you're going to put it where the long side and the short side meet. So it should look like that.
So both pegs are in the 3 sides, none on the 4.
None on the 4. Show them like that, Afak. Show them like that. Show them like that. Hopefully you guys got all the views. You with me, Afak?
Yeah.
All right, let's move on. So we're going to put this on the side. We're going to put these 2 guys on the side here. We're going to grab our motors. We're going to grab our motors. We're going to start putting things together. What we're going to do, and this is where you can kind of get a little bit confused. I need you to pay attention. The side where you don't have your wheel. All right, Afak? The side where you don't have your wheel.
The side with the phone line thing in it, right?
Well, the phone line is on the other side. I want you to consider it this side where there is no wheel on the inside.
All right, got it.
Alrighty. Now I want you to hold it up, okay? So that
you can read the Lego.
So that you can read the word Lego. That's a good way of thinking about it. It's a good frame of reference to use. Thank you, Afak. And then I want you see what happens is we built equal and opposite ones, but our motors are also equal and opposite. So if I try to fit this in like that, that's not quite what we're aiming for. We need it to be, you want to switch, so in fact, the one that you have like this,
so we have their own motors. So basically, they have to go in which holes?
So you read the word Lego, right? And then you grab this long one over here, and then you have 3 holes over here. They connect to your peg. So you want to do it so that it wraps around that circular part where your motor is. So it should look like that.
On the inside. It should wrap around the word L, basically, on the Lego.
It should wrap around the
letter L.
Well, it actually wraps around the letter O on the word Lego as well.
Depending on which way you hold it.
So they're equal and opposite. So I want you to give them a view of how that looks, in fact. See how that is, guys? Perfect. Then
it should be on the inside of the wheel, basically.
Right side of the wheel.
There we go.
So then we're going to grab this L piece that has the 2 connectors in it, and we're going to stick it up so that the long side is facing up along with this one.
This way?
That's it.
Yeah.
Yep. That's how it is. So this is where we are so far. Hope you guys are all following along.
Pretty simple so far. I'd say so. It's like we're kids again.
you never feel like you grow up, really. So then, we're actually going to bring our EV3 brick over. If you guys are at home doing this with an NXT, it's completely acceptable. All the pieces are the same. All the connectors are the same. It is backwards compatible. So, I want you to hold that for me, Afak. We are then going to need these little pieces, and these ones have, want to count that out for me?
1, 2, 3, 4, 5.
I'm glad you're counting better. 2 5-connector pieces. You take one and I'll take one. All right, all right. Now, remember those pegs that we had before?
There's 4 left of them.
They're not the right ones that we're going to use for this portion.
Why not?
We actually need ones that are a little bit longer. So
these.
I bought these out just to kind of give you guys a frame of reference for the ones that we're going to be using. If you hold them up next to each other, the black ones are a little bit shorter than the blue one that I have. Now, I just want you guys to know that there are black colored ones, just like this one. The color is not important, the shape of it is.
So, Cleve, just to recap, the 3 connectors that we're using in this project are 1, the axle one, which is a connector on one side, and an axle on the other.
And then we have our peg,
which is just a connector on both sides.
And then we have the extended peg. So on one end, it looks just like your normal peg, in fact, if you take a look at it. But then on the other end of it,
it's twice the size.
It's twice as long.
Okay.
So you guys will see the functionality of that. So I'm going to take these 4 over here. These short ones, we're not going to be having a use for them in this part of it. And then we're going to need 4 of these longer ones.
Okay.
Now, I'm going to divide it by 2.
2 for me.
Why do you think I divided it by 2, Fak?
2 for me and 2 for you.
Why?
Because we have 2 sides to the motor.
There it is. And like we said, it's equal
and opposite.
And opposite. So, first thing we're going to do is we're going to take the 5 connector that Afak showed me in the beginning, and we're going to do them, interestingly, this time we're not going to do it equal and opposite, we're going to do it the exact same if we're looking at it at the same end. So I want you to put the long end into your connector so that when you look at it from the side, you have the same, roughly the same height. I want you to do that in the first hole or the last hole, and then I want you to put it in the middle hole, which is the same regardless of where you start to count from.
It's the 3rd hole.
3rd hole. So if you put them next to each other, they look exactly the same. We're not holding them equal and opposite, we're holding them in the exact same way. You guys are going to see how that's going to work in a second from now. Then I want you to grab your NXT brick. Now, if you look at the side of the NXT brick, you have your screen and you have your buttons. The side that has the screen has these connectors on it. What we're going to do with these connectors is we're going to connect the 5 connector
that we just built
with the 2 bottom ones going like that, so that it extends a little bit above the robot. You want to snap that in for me, Fak?
Yeah, so what you're telling me is if I'm looking at my EV3 or NXT at home, I should see the screen and then the buttons right under it. And then right to the right and the left of the screen, there are these little pegs that also make an L. 3 vertical, 3 horizontal, 2 vertical.
Now you're getting it.
And I'm sticking into that one. Not the one closer to the buttons.
Not the one closer to the buttons, the one closer to the screen.
Okay. And I just stick it right in there?
Yep. Now, this is the big step. This is where you're really going to start seeing how your robot is going to come together. You're going to grab your wheels. Grab your wheel, Fak. You ready?
Got it. Let's do this. I'm scared.
And you get it. Don't be scared. Everything is going to be okay. You're going to need to play with it a little bit.
Well, tell them what they're supposed to do first, and then we figure it out.
Well, let me take a look at it. Let me see if I can figure this out. And this is what goes into a lot of the engineering that we do. Sometimes it may not be clear right off the bat. What I'm going to try to do is I'm going to try to connect it into this portion in here. However, if you guys can see, it isn't quite lining up. So at this point, what you're going to do is you're going to try to play with it. You see if you can make it work. So these 2 connectors over here, if I take them off, I'll be able to line up cleanly with the robot. The word for that is flush. And if you see, it's not playing around. It's completely okay. A little bit of technical difficulties. Sometimes you got to improvise on the fly.
So again, the problem with that was that these are NXT motors, and that's an EV3. The EV3 is a little bit longer than the NX3. So when we had made this, or Khalid had made the 5-minute bot, he was using NXT. However, this just goes to show you, Legos are amazing, and you can always work around what you got.
So if it doesn't work, just try again.
Make it work.
By no means is this a perfect robot. This is just a place for you to start. You tweak it, you play with it, and you make a better one. You want to do what I did over there, Fak?
Please. So I just connect it nice and comfortably?
Nice and flush. So for you guys at home, this is a lesson to you in real life and in engineering. Things never go as planned, but you got to improvise on the fly. Otherwise, you're going to wind up looking like a big doof on YouTube.
What do they call it? They call it Murphy's Law. Anything that can go wrong will go wrong.
No, Murphy's Law is anything that can happen will happen. So evidently, this could happen, and it did happen.
Look at that.
So then I want you guys to place your robot upside down onto the table.
Looks like a little crab upside.
With wheels. If you see one of those, you let me know. We're going to grab a 15 connector, and there's only one of these.
We're only using one?
We're only using one 15 connector.
So that's 15 holes. Again, that's how. So everything in Legos is based off of these.
The measurement for a lot of the things in the Legos, well, you can't really measure your wheels in hole sizes.
Well, I mean axles and stuff.
Nothing is perfect, you know?
That's kind of smart what they did, though.
It's a clever thing. I really like it. So then what we're going to do is we're going to bring back these little pegs over here, and we're going to need 1, 2, 3, 4, 5, 6, 7, 8 of these little black pegs. So can you grab that for me, in fact? We have 1, 2. How many you got? 3, 4, 5, 6, 7, 8.
And now, again, for everyone at home, these are not the axle pegs. These are not the long pegs. These are the original little black connector pegs that we have been using since the beginning.
That's right, that's right.
Okay, so now we got 8 of them.
And I also have my Lego kit right here, because we are also going to need a 3 long piece like this one.
That's the yellow ones right here.
We got them?
The yellow ones.
Wonderful. So in ours, it's yellow. In yours, it may be a different color, but what's going to be exactly the same is that they're 3 long. So to recap, we have 2 of them that are 3 holes, one of them that's 15 holes, and then we're going to have 8 of our peg connectors. Not the long connectors, not the axle to peg connectors,
The
just
original connectors.
peg connectors.
Now what are we doing with all that?
Side. Well, what we're going to do, in fact, is that we're going to take our piece that's 15 pieces long, and then we're going to place a peg connector on the 2 outside holes on both sides. So let's do that together now.
Facing us, I guess. Yeah.
Facing up. Well, if you have it down, you have to do it facing up. So if you take a look at it, that's how it's going to look. And then we're going to take our robot. I'm going to do a little bit of surgery. Our crab robot. And we are going to take 2 peg connectors, and we're going to put them on the side that's closer to the wheel. So on my side, it'll be these 2 holes, as you can see. This hole and this hole.
But also, what if someone gets confused? There's identical 6 holes on top of the robot. So this time, we're using the 6 holes on the bottom, which means under the buttons, not on top of the screen. That may be a little confusing, but if you're following along at home, you can figure it. It's not too hard to figure out.
You want to do it actually on the side that has the holes for the motor.
I'm gonna take a wild guess here. Are we doing this to set up the front wheel?
Maybe it's the back wheel, depending. What if your robot goes backwards? And if you're using a crab robot, isn't it supposed to go sideways?
Well, I'm gonna call it the front wheel because my car has big 2 wheels on the back. So then obviously it would have to go. If we're making a front wheel, it would have to go in the front or the bottom. Again, frame of reference.
Pretty good guesses, in fact. So let's stick our pegs in. So I got 2 pegs on this side.
I got 2 pegs on this side. Not yet. Now I do. Okay.
Now we got our 15-piece long connector. And we are going to try to connect it like so. Now, this is not the first time in our presentation that something has gone wrong.
Shows ingenuity. So now we use the long connectors.
If these pieces are not going in, what we could do, we could take this 15 piece and connect it across our robot to these 2 pieces. So, we'll do that again just so you guys are with us.
Oh,
well, that's a live one. We have 2 and 2, and then we have our motor. We are going to stick it in. If you look, probably lines off with this.
So we're just connecting that right in there?
We're going to click it into the motor on this side and the motor.
So the motor also has 3 holes on the bottom under the telephone wire port looking thing. Am I right?
Yep. So what we're going to do now, in fact, is we're going to go ahead and design our front wheel. So you're going to have these little wheels in your set. The way that these little wheels are is if you hold them, you can count 1, 2, 3, 4, 5, 6. That's 4, 5, 6 holes. So this is another measurement system. This is another measurement system that LEGO has implemented in their Mindstorms kit, NEV3 or NXT kit that you're using. So we have these 2 wheels, and then we're going to need a 3.
And again, that's measured by the holes in the long pieces.
And if you guys would like to verify that, we have our 3 long axle over here. We place it next to the axle. It is a 3 axle. Now what we're going to do here, in fact, is we are going to place these wheels next to each other.
Okay.
Now if you can just stick an axle between these for me.
I would love to.
Thank you, sir. Yeah, you got that. Now while he's doing that, I want to show you guys this little piece over here. The way it looks is it has the little plus sign, multiplication, cross, whatever you want to call it. And then if you hold it up, it looks like a T, but when you turn it, there's a hole in it. So basically, it's a hole, and on the bottom, it has the cross. At this time, I'd like to remind you guys, if you have any questions, please, please, please feel free to reach out to us. We're here to answer your questions. Very good, in fact. Then I want you to take, we're going to need 2 of these. So, in fact, you have the other one like this one?
That one.
And then you're going to need an axle to peg connector. I have one. Do you have one, in fact?
Can you please pass me one from the kit?
Oh, Legos, you're always getting lost. Someone will find it when he steps on that one.
Then we'll never hear the end of it.
And then we'll never hear the end of it. It's your fault, not my fault. I'm teaching you.
And while he looks for that, I'm just going to skip ahead and assume that the axle axle peg connector. Again, axle on one side, and peg on the other. We're going to take the axle side. Sorry. He was a little enthusiastic there. We're going to take the axle side and stick it into the bottom of, what would you want to call this piece?
Let's call this the T piece. It's like a small T if you look at it from the top.
So we're going to stick it in the bottom of the T?
You're just going to stick it right in there like so, push it in there, and it'll come out.
Now it looks like an extended T.
It looks like an extended T.
Okay.
Good guess on your part. If you were wrong, we were going to send you home, is what we were going to do.
So now what are you doing there? You can't just do stuff that's on. Come on.
Well, I'm kind of just noodling around with it. I want to see what's happening. You're going to take your axle, right? You're going to take your wheel, and then you are going to place what we placed on it on either side of it.
Ah, okay.
Now this gives the wheel the freedom
Are you going to attach this
to
to
rotate.
this?
But in fact, it kind of seems like it's moving around, that it won't work. It'll fall off.
But what if it's locked in, though? Once it gets locked into the axles, it won't come out.
But this is too short. What are we going to do to lock it in?
Well, we can stick it into the holes that are already in here.
But what did you just do? You just took that out.
I understand, because this was blocking it off before. The beauty of engineering.
Designing on the fly. I like it. But wait a minute. We stick these two pieces in here, and our wheel is too close to the NXT.
So what if we go back to the three pieces that we had before, and we extend them? So we're going to take the black connectors, and guys, this is us. See, you have full creative ability at home, and we're taking that liability right now to design our own robot. So I'm going to try to put a little bit of my engineering finesse into this, and I'm going to ask you guys, I'll show you in 1 second. Can you get me a black connector, please?
You're talking about a long connector or maybe a short connector?
Regular black connector.
Let's see what we got.
So now, originally, you had mentioned how there are 6 holes on the bottom of the EV3, on the back side of it. Under the screen, under the buttons, we're going to connect the black connectors right to these holes. Now, remember how we found these yellow 3 pieces earlier? If we put these right on top of that, it basically extends this so that when we connect this wheel into here, it actually does not hit the floor anymore. And now we have our front wheel, which is locked into place.
Wow, would you look at that? Now, in fact, these motors are kind of opening up, and I feel like that's not going to be a good way to work throughout this project. What can we do about that, in fact?
So if we try connecting the connector, the 15-piece connector, straight on top, we run into one problem.
And the purpose of doing that is just to give these a stability so that they're not popping out.
But there's a problem. The connectors don't fit.
You're absolutely right. Now, I think we had...
solution. There are 3 types of connectors we went over, Fleet. One was the axle converter. Would that
we
help
had...
here?
No.
What about these things? The longer ones?
Why would you say that, in fact?
Because it gives us more length now. And maybe that's just enough to go right over it.
Let's give that a try. So, stick 2 in there.
Let's see if this works. And whoa, you look at that.
I think that today the teacher has become the student.
So I won't get sent home?
I think they should send me home.
And well, does that solve our problem of locking in the motors?
The motors are locked in. The wheel can spin. You guys have your robot.
Crabbot.
Crabbot, robot.
And if you check,
our FactBot.
It does move.
So basically, this is the hardware portion of your robot. Like we said, you guys can build on this. You guys can throw out this design, do your own design. Point is, as you're playing with the Legos, like myself and Afag did today while we were doing this, you take a look at it, you see if it works. If it doesn't work, try something else. At the end of the day, you'll have something that is completely yours.
You build around it. Now, I do have a question. How does the EV3 tell these motors how to move?
Well, we have these things called cables.
Well, look at that.
Where'd you get those?
Over on the side. I hid them from you.
When did you become the teacher?
These are those phone port thingy things I was talking about before.
Well, these phone port thingy things that you're talking about
Phone cables.
are actually the way that your robot communicates with your motors. So earlier I told you guys that there was a connection side on the motors. Now, you have one connection.
The phone port motor.
The phone port motor. I'm turning this on. Not yet. Not yet. You have your cable. You have a connection on the motor, and you have a connection on the robot. What you're going to do is you're going to connect the connector
into the thing.
Into the motor. I don't want you to connect it to the robot yet. Now, the reason for this is this. If you look at your robot, you have a whole bunch of connections. You have, on the top side by the screen, you have A, B, C, D. And on the bottom, we have 1, 2, 3, 4. And if you're using the NXT, you only have
A, B, C.
A, B, C, D, and 1, 2, 3, 4. Right? You actually have the same thing.
No, there's no D on that. There's A, B, C.
Would you look at that?
So the NXT actually has one extra phone port.
EV3.
The EV3. I'm sorry. The EV3 has an extra cable port. So, Cleve, I've done a little programming in my day, and I'll tell you that, as everyone at home will see as soon as we start programming, when you set up the motor, it doesn't give you the option of numbers, but it gives you the option of letters.
Does it?
So what we're going to do is we're going to take this phone wire, and instead of putting it into the 1, 2, 3 port, I'm going to put it into A and B. Now, this is very important, because when you start programming, again, this is a simple robot, but in our future videos, as we'll see, we will have more sensors and more motors and a whole bunch of stuff, which you have to start keeping track of what is placed in where. Because when you program with a computer, you have to tell it which motor, which port sends out which signal to what motor.
So basically, you're telling me that if I were to connect a motor to A and C,
and I told the computer to do A and B,
it would only A would turn on because it didn't know that B. So you need to be very careful then with where you place your motors and how you connect these motors to the robot.
So I'm going to go ahead and turn this on, and I will connect it to my computer using the USB port that comes with the EV3.
How'd you turn it on?
There's a button right in the middle.
You just press it. Who taught you that?
I press buttons.
Aha.
So now I'm going to attempt to share my screen here so that we can follow along with.
So today what we're going to be working on for the programming is we are going to tell the robot to move forward, we are going to tell the robot to move backwards, and we're going to be doing a basic turning maneuver.
Turning, I think, is next time. Today is just forward and backwards.
We'll see.
We'll see what we have time for. Well, I assume everyone at home can see my screen yet? As soon as we set that up?
So before we get into that, give you guys a little bit of background on programming and a little bit of computer history. Back in the day, before the computers that we use today, there was something called a command line interface. And before the computers, before we had computers like the computers we have today, people would have to type in code to get their computer to work. But then they came up with something called a graphical user interface, which is where you have pictures and you use these pictures to use the computer. And the really cool thing about programming these robots is that they use a graphical user interface. So it's really simple and it's really easy to use. Show them what that's like.
Now that everyone at home can see my screen, my beautiful laptop screen,
yeah,
you guys can see that I have, when we start up the EV3 program called Lego Mindstorms EV3 Home Edition, which is free download online if you guys don't know that already. You see just one big play button. However, if I press play, there's nothing here that tells the robot what to do. Now, if we look to the bottom over here, there are a bunch of these little blocks. The one I'm concerned with today, Cleve, is this one. If I hold my mouse over it, it's called the large motor, which also bears extreme resemblance to the motors we have here.
It's not the one that we're using today, though, is it, a fact?
It is, except for that it's orange over there. It's red over here.
So we're using the large one.
2 large motors.
Despite the fact that we don't have a red one, we have an orange one, but it's the same one.
Same one. It'll serve the same purpose.
I trust you fully.
And now we're going to basically just grab the block and drag it up. And if I drag it up, as you can see, my computer gives me a predestined spot of where it wants it to go. And that just shows that it's connected. Now, when you look at this block, there's a whole bunch of things going on. The first thing we're going to notice is up here, port A. Is that the port we connected into? If I change this to port C, what would happen, Cleve? Take a walk with this.
Well, I think that would only power motor C. I think it would only tell motor C to go.
Well, what's the problem with that?
We have 2 motors.
And are any of them connected into C?
No.
We have A and B.
We have A and B, but
so
I'm a little confused. In fact, you only have 1 motor up there. Shouldn't you have 2 motors?
But
we'll move at your pace.
we will drag it. Khalid already wants us to do it, so we will move ahead. We will drag another motor up, and as you can see, another predestined spot. Now, if I don't put it there and I put it here, it's not connected. You guys can see it's a little dulled out. So if you do want to put it somewhere else, you can drag the wire from here and actually connect it on your own. And once that happens, excuse me.
So one thing you guys should know about programming these programs is that they are linear. They happen in order from how it goes. So that actually tells us that this program is going to turn on motor A and then motor
A right now, but we will change this to motor B.
The way that there's actually a block in here that allows you to turn both of them on at the same time.
That would be the steering block, wouldn't it?
It would be.
As you can see over here. I'm not going to connect it. It's all personal preference, because if we do it this way, if we do it the two-motor way, we can give different power to different motors. If we do it this way, both motors will have the same power. As you can see, it's not connected, so it's a little dulled out, but it says A plus B over here. So as Khalid mentioned, this will move both motors at the same rate. However, what if I want one motor to go faster than the other, which would in turn make it turn, wouldn't it?
Is that how you would turn?
That's how you would turn.
By going different speeds?
One would go faster, one would. Or you could also make it go in reverse.
Here's my favorite thing about programming these guys. Once you set up your blocks and your robot is connected, you can just go ahead and download this program to the robot and run it while you're connected to see what happens. So let's go ahead and do that and see what we have set up.
I will. So we're going to remove the A plus B block. We're only going to work with the
How do you remove it, in fact?
You just drag it all the way down until you can't see it no more. Out of sight, out of mind. So
that's a good one with me.
Again, this is all personal preference. If you guys look at this little circle with the number sign in it, that means that for this many rotations, the robot will move. I prefer seconds, personally. I feel like it is easier, so I'm just going to move this to seconds.
So you're saying that when you set that in the block, it tells the robot to move for a certain amount of seconds.
Before it was set to rotations of the motor.
So that means that the motor would have to do as many rotations as it likes. So what is one full rotation?
360 degrees.
So basically, if we have a point on the wheel over here, we just have to go right back to where it started, and that's one full rotation.
But again, personal preference, I prefer seconds.
Like we said, noodle around with it, try it, see which one works best.
So I will turn these seconds to 4 seconds. Let's make this robot move for 4 seconds. So that's the second screen. Now on the left is the power screen. Now if I wanted to make the robot go backwards, I would move it to negative power. But right now we just want it to go forward, and we'll leave it at power 75, which the computer told me to do originally.
So 75 is the default setting.
Yeah.
And a positive number means you go forward, and negative number means you go backwards.
You're catching on quick.
Hey, I have the best of teachers.
And now at the end of the robot, you see this little thing. Now if you read it, it says break at end.
What does that mean?
It means true.
It means true?
But
what do you mean by that? I think it means that at the end of your block, your robot breaks.
Yeah.
So it breaks at the end of that block.
Now, you just made me realize something, Khalid. This wouldn't be the right block I want to use, would it?
No.
Why would that be?
Because I think that if you follow those blocks,
yeah,
it'll execute the first block. So the block A, the one that I'm using my mouse around right here, it would do everything in this block.
Play it. I'll hold it up because we'll see what goes wrong with this. Now, I want you guys to carefully watch the wheels. I'm not going to put it down because I don't want it to fall down, but just carefully watch the blocks. Now, what I'm going to do is
you press the big play button?
Yeah. As you can see, only one of the motors is moving at a time. That's not how a car moves, if I'm not mistaken.
Let's see what that looks like on the table.
We're going to press play again. Let's see what goes on. It's just not what we wanted to do at all.
Maybe your car does that, not my car.
So, back to how Khalid mentioned the A plus B blocks on the bottom.
Those, I think, are going to move both of them together.
That's what the plus means.
So what we just did to show you guys that these programs run linearly. They don't run at the same time, the blocks. They run the way we have it set up at the moment, one at a time. So it has to do the first one, and then it will do the second one.
So I'm going to get rid of A.
Later on in the workshops, we do things where they run at the same time, but at the moment, we're going to be running linear.
Yeah. Now, we have the steering block again. I
want
to change it to
similar.
Seconds. It does, but do you see how it has 2 motors on the screen?
Mm-hmm.
That shows that it's going to move both at the same time. Steering, how a car moves. Now, again, I'm going to change the seconds to 5, leave the power setting at 75. However, this one has another interesting thing, which is steering. Steering, as we all know, is which way the car is going to move. Right now, we want the car to move straight.
So what do we put in?
It's just 0.
So let's run that and see how it looks.
However, interestingly enough, I've come across robots where even though it says 0, it's going to veer off to the left.
What can cause that?
Just calibration, motor speed, just a lot of different things. So to combat that, if it's moving to the left, we would turn the steering to the right, which would hopefully align it to the center. But right now, we don't know how it's going to run, so we are going to align this to the center. Now, I'm going to move my computer back a little, and we will make the robot. Now, ideally, this should run straight. Let's see what happens. And when we look at that, ran straight. So 5 seconds was a little longer than my table. Let's try to change that to 3 seconds. 2 seconds. And if we play that, now let's see what happens if I can turn this to negative. Leave it. I want to see something. If we turn that to negative 75.
Negative power.
Negative power. What do you think's going to happen?
I think it's going to go backwards.
Right back to where it started, ideally, right? Let's see. Well, look at that. Crabbot moves.
Can I see what the turn looks like, Afak?
For sure. First, we're going to turn this power back to positive, because now we don't want it to run into the iPad. But let's make it turn a little. So it was going a little off to the right, getting off the table. So let's make it turn towards me. I want it to come towards me. It's my robot. So I would change this steering direction to the left. Let's make it go left 25. Let's see what that looks like.
Let's see it.
And it came right to me.
Lo and behold,
look at
it's
that.
like magic.
Now, I want it to go right back to its starting spot.
Not going to pick it up.
But you see how beautifully it turns negative 25 on the steering all on its own?
So that,
So I don't have to change that at all. And there you go.
It's almost like it parked the car.
Now that we're satisfied with this program, we can just hit this download button right here, and that beautiful sound will let us know it's downloaded. And now we don't need the computer.
Unplug the wire. So what you do is if you're at home, you have 4 icons across the top. I can't quite show you on the camera, but you have 4 icons on the top, and one of them looks like a play button, one of them looks like 2 papers, one of them looks like a Lego brick or 6 circles, and then you have one that looks like a wrench. I need you to go to the one that is immediately to the right of the play symbol, which looks like 2 papers, and to do that, you just use the keys on the NXT brick. You press the right button, and then you're going to go to Project. Then you're going to go to whatever the name is of the program that you had on your computer. Ours is named Program, and there's going to be a little play button next to it. All we have to do is we put the robot down, and then I press the middle button to select it. What do you think is going to happen, Afak?
I want it to come to me.
So it's going to run the program that you put on there just a moment ago.
Yep.
So we press play.
I knew that would happen because I'm pretty sure I downloaded the program that was still negative.
Yeah, let's put the actual one on there.
So, or we could just put it right back here and see if it goes back to its original spot. So again, I'm just going to press down on program.
So
it works. It's alive.
A few tips that I would have for you guys when you guys are doing this is definitely use a ruler, definitely use your stopwatches, and keep on doing it over and over and over again. So, for instance, if me and Afak were to want to figure out how to get this robot to the end of the table, perhaps we could set it on a particular speed and set it for more seconds than required, and we would time how long the robot would take to go to the end of the table. And once we get that exact measurement, we can get the robot to go there no problem. But in order to do that, like we said, design and engineering is an iterative process. It's repetitive. You're going to do it again and again
and again
and again,
and improve upon it ideally every single time.
So let's see if we can do some more programs for these guys.
Are we? I'm pretty sure we are. We have 5 more minutes. Okay. Well, we can play around with the program a little more. Okay.
Let's noodle around with it.
So, back to my screen. If I connect this up again.
In fact, can we do one where the robot goes straight and then goes backwards in the same program?
We're getting a little advanced here. You know what? I like these guys. We can make this happen.
You think we can do that?
We can make this happen.
For them.
So,
I taught you, you taught me, and let's teach them.
Right now on my screen, we still have the negative 75, the negative 25 steering, just one block.
Okay.
So what we're going to do is we're going to make this positive again because it's over there.
All right,
So make that. Let's make it go slowly.
All right.
Let's take that to a power of 25. Turn the
So
settings to
lower,
0.
lower than the default setting of 75. Now I know a lot of you guys are sitting at home and thinking, you know, it would be interesting setting the power to 100. Yeah,
do that later.
but that when you set the power to 100, and this is something that I've personally come across playing around with these robots, is that the robot kind of gets jittery. It's kind of like when someone drinks too much coffee and they're moving way too fast. The best thing you want to do is you're going to keep it at a power of maybe 80. Don't go over 85, but you don't have to take my word for it. You have it at home.
Some people like to live fast, man.
Yeah, but then the robot is not going to do what they want it to.
Live fast and die young. So we already have the program for it going forward. Now I'm going to take another steering block and bring it down. Ideally, I would put it right next to it, but I have this big. You know what?
How would you close that? There you go.
So right now the program is still set to forward. So what I'm going to want to do is turn this to negative 25. Steering the same, but some rotations. I want to turn this to seconds. Same thing. Let's run this.
So wait, before we run it, in fact, what is this program doing? Now, if I'm not mistaken, you're going to go forwards for
this one
2 seconds
at a speed of 25,
and then you're going to go backwards
for a speed of.
Let's make it 2 seconds so it goes back right where it started.
That's fair. And do you want to download this or you want to play it off the computer?
Let's download it so we can take out the wire.
No wires, no mess.
Sound is working good. Let's connect it. We are going to go to the program. So like I said earlier, you're going to go to the icon on the top that has the 2 papers. You're going to press project, and then you are going to go down to the name of your program. Our program, as you saw on Mr. Effect's screen, is program. And then I'm just going to press the middle button to select it, and
notice it's going considerably slower now.
And it did exactly what we wanted. It went forward for 2 seconds, and then it went backwards for 2 seconds.
Now, I want it to go to a speed of 100. I want to do power setting of 100. Let's see how this works. Let's go back and change this power setting to 100. So this is the fastest the robot's ever going to move. Do you want to download it again?
Let's download it on there.
So this Mr. Euclid said this is where the robots get a little jittery, but I like fast. I'm a fast guy. Let's see how this works. It should go. I mean, so the 2 seconds at a power of 25 came about this far. So
you put it on
this actually might just come off the table. So I'm gonna hold my hand right here. Let's see how this works. Just in time. Do you notice the difference in the speed?
Fantastic. Just for your reference, when you guys want to go back, you got this button over here on the top, and it'll take you back in the menus to where you started. And if you press it enough times, it will help you turn it off. And like the fact said, despite the fact that we had the motors on for the same amount of time, since the power and the speed was different, we go farther. So that's just something for you guys to think about at home while you're building this.
That is it for the programming today. Did you have a lot of fun? I had a lot of fun. I learned a lot.
Well, I had fun teaching you, and I had fun learning from you.
It's always a pleasure.
I'm glad we can help you guys out.
I hope everyone at home had just as fun. We'll be back here next week at the same time. And next week we divulge a little bit deeper.
We're going to go a little bit deeper into the programming. So hopefully next week we intend on bringing you guys a bit of a more advanced robot. I hope you guys have more robots, and hopefully you guys have some questions. We do have the email that we gave you guys. I'll give that to you again. That is Center for
K12STEM@gmail.com.
So you definitely could email us live while we're running this. It was our pleasure, guys, and thank you for tuning in.